Let's solve another Leetcode problem today. Today, let's solve the problem of 25, 21. Distinct prime factors are product of array. So we are giving an array of positive integer nums. Returns the number of distinct prime factors in the product of the elements of nums. This means we are giving a numbers array like 2, 4, 3, 7, 10, and 6. We need to find the distinct prime factors. First, we need to get the product of the numbers. So the product of the numbers is like this number, 180. And then we need to find the prime factors. So here, 2 to the power of 5 times 3 to the power of 2 times 5 times 7. We need to get these four numbers, 2, 3, 5, and 7. So this is the meaning of the problem. Return the number of distinct prime factors in the product of the elements of nums. So this is a product, and this is the distinct prime factors. So we don't need to count 2 5 times, only need to count 1 time. So this means the distinct numbers. So how to solve the problem? There are two ways. We can use select or save, or acytosis save to get the numbers, but that is not necessary. We can just use a simple method to find how many prime factors are. But we don't need to solve the problem of the product and then find it one by one. We can find it directly. For example, from 2, we can find, 2 is a prime factor, but when it goes to 4, 4 is not. Right. And when it goes to 3, 3 is a prime factor. But for this 4, it equals 2 times 2, so we get a 2, but we've already found a 2. It doesn't matter. When it goes to 10, it is 2 times 5. We don't have 5, so we need to put 5 into our result. Like this kind of data structure, we can use a set to reduce the duplicate of numbers. So let's get started for this question. We need to have a set, and then we need to check the numbers for n in nums. So n is a number, and then we can check the prime numbers. So we can use the formula for I in range 2 for n in nums. For I in raise 2 to the, let's get a int n to the power of 0.5 and plus 1. We have to plus 1 because the formula need to get that. Otherwise, we cannot get the result. For example, if n is equals to 4, square root of 4 is 2. 2 plus 1, here is 3, here is 2. Yeah, but we will solve that later. But we have 2 plus 1. Let's continue. For I in rates, for n in rates, let's do it like this. Let's first start from I, and here let's start from G. Means two numbers. I is the first number, it's a big number. G is a smaller number. So let's do it like this. Why? Because yeah, because this is nothing, just a different variable. Yeah. So I is the first number, Z is the second number, and I is bigger, and we need to check. if we don't need to do this, we can use a while to check if while I modular z equals to 0, we need to add the result inside. We need to add z inside, and after that I divided by z. We can end as many as we like until at the end we need to check I. If I is equal than 2, we need to put the I inside of our set. After that, I think we can return the result. Let's check. Where is we need to return the set as not result. So here it seems okay. Let's say case 2. Case 2 is also okay. Let's submit it. Yeah, it's submitted. Now let's go back to why we need 2 plus 1 from here. Yeah, from here we need 2 plus 1. Otherwise, we cannot get the result. For example, if I equals to 4 and square root of 4 is 2, here is 2 plus 1 is 3. Here I is 2. So I here is 4. For g is 2. 4 divided by 2. It put a 2 inside. I divided 4 divided by g. G is 2. I equals to 2. Here is 2 modular z. Z is still 2. It is 1. It is outside. Then we put another 2 inside. So it seems it is okay. If we don't plus 1, if I equals to 4, we cannot put the first 2 inside of our set. Right, for example, if I equals to 4, here without plus 1, here is nothing. We just need to do check. If I more than and equal than 2, s will add I. Here will be add a 4 inside. Of course, this is not right. So we need to know how to calculate how to get a prime number. We have 2 plus 1. So this is the formula because this is the number theory. And why here? Because this I, sometimes this I will be equals to 1. We cannot put 1 inside. But if it is not 1, it is more than 2 or equal than 2, after all of the calculations, this I will always be a prime number. This is why at the end we need to put it inside. Thank you.